Welcome to the first set of notes for the circuits unit. These notes are on electrical potential difference, and there's a few things that we're going to talk about when it comes to electric potential difference, or EPD, as it is abbreviated to. What is it? A little analogy to help that definition. Some units and some rules that go with EPD in circuits so that we can apply it to what we're doing. So electric potential difference depends on there's two parts to the definition, and they both come from the name, electric potential difference, the first being electric potential, second being difference. Electric potential is related to electric potential energy. And electric potential energy is it's a common analogy is used with gravitational potential energy. So here can be thought of as our gravitational potential energy. You may have seen this before. Potential energy is equal to mgh, h being height. I want to include a picture here, two pictures, to help with this analogy. The first one on the left here being what our circuit normally looks like. We have a battery that's in series with, it's hard to see. Go here. We have a battery that is connected to some wires. The red spheres here are electrons, and they're being pushed through a light bulb and going around like that, back to the other side of the battery. If this were a 9-volt battery, we would say that this side, the positive end of the battery, has an electric potential of 9 volts, and the other side is at an electric potential of 0 volts. So the electric potential difference of the battery, also referred to as delta V, or the change in voltage, is equal to 9 volts minus 0 volts, being 9 volts. And that's what's on the side of the battery. So you'll see this sometimes used interchangeably, just saying, oh, what's the voltage of the battery? What's the electric potential difference of the battery? They're talking about the same thing. And so here's where we get into, on the right, our height analogy. To increase the potential energy of an object, I need to raise it higher off the ground, essentially. And so when a battery gives an electron electric potential energy, it's kind of the function of the batteries to supply energy to the circuit. It can be thought of as lifting up the electron to a higher height, essentially, where here all of these electrons have some kind of energy, or an electric potential energy, that once they cross the light bulb, that electric potential is converted into other forms of energy, like light or heat. Similar to how if I were to drop whatever it is, let's just say a ball, from a certain height, it falls, and some of that energy is converted into kinetic energy when it falls, 1/2 mv squared. The units of electric potential difference are volts. Volts, which is the same as joules per coulomb. And this kind of makes sense in terms of our analogy, because our battery is doing work, or it's giving energy to a charge. So this is units of joules is a unit of energy over coulombs, which is a unit of charge. So how much energy is the battery giving each charge? That's what volts is. This is abbreviated to just the letter V. And again, you know, volts and electric potential difference are kind of used interchangeably. Voltage in EPD. So I think the rule of thumb would be, if you're asked about a voltage, say across the light bulb, you are really talking about this difference in electric potential energy here. Electric potential difference is that change in height, you could say, of the electron after the light bulb. There are two rules for electric potential difference or voltage in circuits, as in like finding what each of those are. For series circuits, there's series and parallel. For the series, I'm going to call it voltage rule. Voltage rule. I have a series circuit, so my battery, a light bulb, let's say, and we'll have actually two light bulbs. And so I have a voltage here of the battery, and then a voltage across each of my bulbs here, or an electric potential difference across the bulbs, right? We've talked about what the electric potential kind of means, and that difference being, right, the difference from where you started to where you end up. That you would have found this out in the lab, that the voltage of the battery has to be equal for a series circuit to the sum of the voltages involved. And we could have more than two bulbs, we could have 20 bulbs. And it would still be the sum of all of those. For parallel circuits, this is the parallel voltage rule. You can draw a parallel circuit. Actually, I want to make this extra clear. Draw the battery with those alternating lengths of lines, positive and negative terminal. Light bulb number 1. Light bulb number 2. And again, I have a voltage of the battery, and then a V1 and a V2. For parallel circuits, again, you would have discovered this in the lab. The voltage of the battery is equal to the voltage across each of these components, and they are all equal to each other. So in the next set of notes, we will be talking about the other two of our big three sort of variables for circuits. One of them is voltage, or EPD. Second is current. And the third is resistance. done this one today.